Good morning, everyone. Good morning. I'm especially delighted to introduce a very special guest this morning, Noopur Davis, Senior Vice President and Chief Product Information Security Officer in Comcast. Noopur's role is to ensure that security and privacy's best practices are built into all product development and operation activities to mitigate potential security risks. Noopur oversees cybersecurity risk management, security solutions delivery, customer privacy, and security intelligence and architecture. Noopur's leadership in these areas will advance a holistic approach to security that strengthens our ongoing commitment to safeguarding our products, infrastructure, and information. Before joining Comcast, Noopur served as the Vice President for Global Quality for Intel Security Group. Previously, Noopur served as a principal with management consulting firm Davis Systems, working with clients such as Intel, Adobe, HP, and Microsoft. He was also a visiting scientist at Carnegie Mellon. I don't know where that is. University Software Engineering Institute. Welcome to SOARS and welcome to the conference.
Thank you so much. Thanks. I don't need this, right? So, okay. I have a really loud voice, so I definitely don't need 3 microphones. So thank you so much for that introduction. Beautiful day outside, kind of crisp and sunny, and so it's hard to be indoors on days like this, but hopefully we'll have a great day and everybody will enjoy being indoors. I want to start very briefly with talking about Comcast and our scale. So I joined 9 months ago from Intel, and Intel had scale. We have huge fabs and huge manufacturing scale. But this level of scale I was not prepared for and didn't even know that this was the scale that Comcast dealt with. So I'm just going to zoom in and walk through a few of these numbers with you. And it's important why I'm going through this, and I'll make the connection in a second. So if you go from your left to your right, we start with just our customer-facing scale. So that is your 9 million support calls. And remember that a support call is a vector, right? For social engineering, for all kinds of, so we do 9 million of those a month. We do 365,000 truck rolls every month, if you start looking in the middle, we have 60 million website visits to our main digital properties. The voice team told me that this number is already out of date, but we did, so this is getting closer to 300 million voice commands per month that we process. 23 million video subscribers, and then that number, 500 million, that's billion with a B, video on demand every month. And then if you start looking in the middle, we have about 14 million Wi-Fi hotspots and access points around the country, about 24 million internet subscribers. And then this number, 320 billion monthly DNS lookups. So here we kind of swap positions with Google. So they're number 1 sometimes, and we're number 1 sometimes. But number 3 is like way below that, right? So by far, we are leading in the world in how many DNS lookups and the whole infrastructure that supports that, right? And then if you go to the right, there is the back end that supports this level of infrastructure. So we have 9 million miles of fiber, 135,000 fiber nodes. I can't even comprehend that, if you just think about just the physical space that would take. And we have almost 750,000 miles of traditional coax cable. Right? So, and then on the very right, we have won some Emmys, which, the team that won that, it was like, you have to put that up there. So now, these are not the glamour Emmys, right? This is not the evening stuff that's televised on television and, millions of people watch. These are the technical Emmys that happen in smaller venues. But very proud of the fact that we have 2 technical Emmys on the whole X1 user experience, right? So when we talk about security, we are talking about security in the context of this scale. So in this scale live our enterprise, our employees and our partners, our customers and our subscribers, and we are responsible for making sure that we are addressing their security needs. So it's a huge undertaking. I have a great team here. Ramesh is here, and Jim Farney, and a lot of other people from our team. A lot of our partners are here. But it really takes a lot of concentrated, planned effort to work at this scale, security at this scale. So this audience knows this definition, but I want to level set to make sure that we're talking about the same thing. When I say, what do I mean about when I say security in this infrastructure and at that scale, right? So I started in security a long time ago, early 2000s, and this definition has actually stayed pretty constant through that period. So we used to call it the 3 pillars of security were CIA, right? Confidentiality, integrity, and availability. And now the C, I see more and more, is being replaced by the P for privacy. But the definition is still the same. So the P is around making sure that our information stays private and confidential, which means that only people who are allowed to look at it, right? So this involves all of the security features and functionality around authentication is one of the key technologies in this space. And the second bit is integrity. So this is making sure that our information is modified only by people who are authorized to do so. So that, when I look at the information, or whoever is consuming the information, that we can be sure that its integrity is still there, right? So this is around authorization and access control and all of those other things that we deal with. And then finally, we could take our information and lock it away and throw away the key and disconnect it from all networks, and it would be really private, and the integrity would be there, but it wouldn't be very useful, right? So availability is that third leg that we have to make sure that, and this is where there is a very, very, very close relationship between security and architecture. So one of the cultural things that I'll talk about later is how we are changing this at Comcast, where we're really starting to look at security from that architectural point of view. Because to be available, you have to be resilient, you have to be scalable, and those are all architectural attributes of a system, right? So availability really starts to tie us into those wider cultural areas that we're looking at around how do we take other classic engineering issues and start making sure that security is really thought and built into those issues. So if you look at the landscape, it is huge. I just started doing dots because they don't fit in on the slide. But again, going from the left to the right, we have all of the hardware endpoints, the networks, IoT. I think Sridhar was here yesterday, and I hated to miss his talk. But this space is, of course, opening up tremendous amounts of opportunity and danger, vulnerabilities in our space. We have to worry about things like access and theft and reputation. There's data and application and services. There's attacks and vulnerabilities. Ransomware keeps growing. That's one of our biggest areas where we see growth, where we don't want to see growth. And then finally, on the lower left is the 5 pillars of the NIST cybersecurity framework. And I wanted to put that just in its own box because there's so much more than just that. And that itself is enough to keep a entire organization occupied, especially at our scale, right? So that is, of course, the identify, where we want to make sure that we identify and manage our important assets. We want to make sure that they're protected. We know that despite our best protection, there will be breaches. So once that happens, we have to be able to detect them as near real time as possible. We've got to respond and then finally recover, making sure that we've put controls and systems in place so that those things don't happen again, right? And so it's a huge landscape, and we have to look at this landscape at that scale that I just talked about in our first slide. So what has to change as we start looking at the technical changes that are coming and the cultural changes that are coming, right? And this is a traditional enterprise security view. Most of us in this room are way beyond this, but traces of this still linger in our culture, right? And the traditional enterprise security view is what is also known as the coconut view of security. And a coconut view of security is that we really spend a lot of time and resources in hardening the perimeter, right? In fact, the first few years of my career, that's what we did. We built tools that hardened the perimeter, we rolled them out, we monitored them, we spent so much time and investment in that. The problem is that as soon as that perimeter is breached and you're inside, there's all this kind of yummy goodness just waiting there. And it's pretty mushy. There's not a lot of hardening there. And you can go anywhere you want, pretty much, right? Now, yes, we try. We do segmentations and zones and all of, but it's still pretty wide open. What we would like is the capability to be able to build, firewalls or some kind of protection, because inside the coconut is where the real important stuff is, right? That's where those assets are that we have to protect. And what would be nice is if we could actually build like little, protection, little coconut walls around each one of those. But with our current technology and the way that we've been doing this, that's not been possible, right? It's that scale is not possible. And the reason that scale has not been possible, and this is changing, and this is what's going to drive one of our culture shifts, is that we have built traditionally our networks and systems bottoms up, right? They've been hardware-based. And this has been, by the way, fantastic. It's brought us to where we are today, where, so I'm not, it was right for the time, and it is still right. But the problem with that kind of a structure is that it is hard to scale, both from a cost point of view and from a speed point of view. Right? It is hard to scale hardware in a quick way or in an inexpensive way. The typical cycles with hardware, I know there's some hardware, I know that Cisco is here, and I know you guys are leading the way in actually this transformation. So, but the issue that we've had is just the cycles that it takes to go through the upgrade. And by the time you get things in and deployed, they're already out of date, right? So that whole scale is really difficult. Now, on the other hand, if you look at where scale has just been easy and has just taken off, is at the web scale companies, right? And there, instead of a bottom-up tradition, there's been a top-down tradition. And instead of a hardware tradition, it's been a software tradition, right? So the scale comes from the apps, the resiliency is built from top down. So it's very easy to scale and grow wide. And what is happening now is the marriage of the two. So if you look at our traditional operating system model, this, by the way, has not changed since mid last century, right? It's pretty much the same from when von Neumann started in what, 30s, was it? So a long time ago. But the basic concept of a operating system that we're all used to is that we have the operating system layer in the middle that abstracts away the detail of the hardware that's below it, right? The CPU, the storage, the memory, the compute, the network, all of that. And on top, so operating systems, of course, are everything that we know and love and hate. Windows and Unix, and we have now just got a small set that are surviving in the industry. When I first started, there were as many operating systems as any company could come up with, right? And what has really taken off, and that is where most of the investment is in that north of the operating system, right? The apps. And there are standards that are developing. There are standard ways that apps communicate with each other and that they communicate with the OS. There's a whole explosion of services and microservices. And that whole area is just exploding and growing in crazy ways. And what's happening now is the same for the network. So instead of the operating system, we have a network operating system. So the traditional data plane and control plane of a traditional network, the control plane functions are now more and more in software, right? And they are migrating to this network operating system. And the same paradigm that we had with our compute operating systems is happening now with the network. So the data plane still is hardware, but it's becoming more and more commoditized, just like it was and commoditized means that the cycles are longer, right? You don't have to upgrade them as often because it's very thin and it's very low level. And as with the operating system, the scale is coming at the network app level. And you look at that north of the operating system layer, and this looks like software. These apps are written in Java or programming languages. The protocols that they're using to communicate with the abstraction layer are software protocols, right? These are REST APIs, and it's just the traditional. The people who are writing those are not network engineers. Their main skills are software engineering, right? So think about what this does to culture. So organizations that have built and designed networks with network engineers and that culture are now coming close together with software engineering and that culture, right? So it's not just a technical issue. The language that is spoken is different. The speed is different. The feedback loops are different. So culture really, really becomes important because of all of these technological changes that are going on. So now the other thing that SDN and then NFV, even more than network function virtualization, is leading to is back to that coconut problem, right? So now with SDN and NFV, we are actually able to have little mini coconuts all inside that big thing, right? So you come in and it's theoretically possible. We're actually doing some experiments with this right now at Comcast. But it is possible now to take an app and make sure that its layer, so the app layer with the web layer with the app layer with the database layer, that we open up the app layer on whatever servers it is, and we open up that one port that it talks to the app layer with. And then the app layer, we open up the one port that it talks to the database layer with. We open up a couple of other ports on the side for monitoring and logging or backups or administrative functions. And we can actually do that, right? So we can take one app and totally lock it down through all of its tiers, except for those particular ports that we want to open where we want to do our. So we can create basically firewalls around a resource, around an app, right? And that is pretty amazing if you think about it, right? So we are now potentially talking about thousands of these in an enterprise instead of the hundreds of firewalls that we manage today and which are difficult to do, right? So that's where we're headed. And what this, of course, ends up doing is, the analogy is like to a ship, right? Where even if the hull is very strong, but even if you're able to puncture that hull, there are these little compartments, right, inside where, now they're used for ballast and other things as well. But one of their main functions is that if it's penetrated, water doesn't go from one segment to the other segment of the hull, right? This is what we're now able to do with this capability. The people who are going to do this are now going to have to work in a very different culture that our traditional workforce has been working in. So I'm not going to go through all 5 of these hurdles to network function virtualization, but the big one again is culture and open standards. Because remember when I showed the diagram, the standards that we're using for these are very, very open. These are open APIs, open communication protocols. So the opportunity is great, but so is the risk. How do we make sure that when the network is so programmable that the people and the applications that are doing that programmability, we secure that whole process, right? It is a big new challenge. I don't know if Assad is here. I stole the slide from him. Assad, you're there. So Assad, I think you used the slide here last year, right? So I just used this and added a few numbers. But this is the other cultural change. So the other technological change that's going to impact culture. So the first was the virtualization and software in networks, the new scalability. The second is IoT, right? So this is going to really change the way that we think and work about security. And here it is, again, sheer numbers. So the technology is going to really, really drive people's expectations of of privacy, right? That first pillar is different in this age. When there are cameras in your daughter's bedroom or your child's playroom, your expectations are much different, right? And that culture that we have to grow around that becomes much, much, much different. By the way, the technology here, the technological challenges are huge, right? So, our traditional ways of authentication, for example, don't work here. When we get to 10 billion, 50 billion, you can't use things like certificates anymore, right? I mean, can you imagine 50 billion certificates? I don't think any system could handle that, right? So we're looking at, what are some other technologies and capabilities here, like blockchain or sidechain, or to start exploring this area. So the drivers to the culture change are, I've talked a lot about technology, and I'll talk a little bit about the people part of this as well. So for our business, it's not just NFV and SDN. It's OTT over the top. It's COAM. It's cloud. It's our shift to microservices. It's internet TV. It is. So in our business, it is all of that's happening. And then, of course, if we go and look at the culture bit of it, the whole DevOps culture is changing the way that we do security, right? So how many of you here have worked with DevOps teams? Quite a few, right? So when you talk about DevOps, the thing that people always talk about is speed, right? It's so we have our X1 teams are releasing updates. 35 last year we did 3,500 plus updates in 1 year, right? So I came from the time where release cycles were 18 months, and we would still struggle to meet those, right? And now we're talking about one every couple of days on average. And the goal of the teams are to keep contracting that shorter and shorter, right? So the way that our teams work is from the time you make a code change and you click a button to the time that it's released, it's mostly hands-off, all automated, right? And we don't even have staging stages in some of our DevOps pipelines, right? We go straight to production. That implies enormous culture change. right? Because think about what that means. That means that we've got to have tremendous amount of automation, tremendous amount of metrics, because as we release into production, you don't just release to that scale, right, that I showed you. You don't update 25 million subscribers at once, right? And you don't update that entire network at once. So we have throttled releases, and each part of that is measured, and they're well-known signatures. So we know at any point, how is this small change that we made, how is this impacting our entire network, right? Whether it be our enterprise or our subscriber network. And because the changes are so micro, we can roll them back at any time, right? So those capabilities, now imagine putting security into that pipeline, into that fast-moving, fully automated pipeline, right? That brings in a lot of challenges. Now, these aren't just technical challenges. These are cultural challenges, because the other thing that DevOps teams do is they want to own the stack. So they want accountability as well as responsibility for the whole thing. That's why we have developers and testers and operations all working together, right? It's not, so it really is beginning to end. So from the time that you think about a product through its operation and maintenance, the teams are working together, right? And the teams stay together with that product. So the cultural changes that are required for that are different. And then finally, knowledge work. How many of you have heard that term? So that term's been around since the 70s, right? A long time. Peter Drucker was the one who coined that term. And it's become fashionable again, but it's old. It's been around for a while. But that is the other thing that is happening in our DevOps team, is this whole concept of knowledge work. And knowledge work is all around, the best example that I have is, if I walk by our offices, and somebody is kind of leaning back in their chair, and their eyes are closed, and feet are up on their desk, what would your response be as a leader in that org? So you may think that they're taking a nap, right? But possibly that is the thinking time, right? That's where somebody is really kind of sitting back and really thinking about the next big thing. So my whole point is knowledge work is mostly invisible, right? It is not visible. So a culture that encourages that and doesn't demand visibility at every step, but visibility at some edges so that you can see what is being produced, but you're not micromanaging or thinking about how that knowledge work that's done in your head is done, is also something that's going to impact the way that we do this work. So the new buzzword is DevSecOps, and some people call it, at Amazon, they call it SecDevOps, but I think the more, one team that I was just talking to the other day at work said the acronym is going to be so long that it's going to take like a whole page to. So now we're putting together security operations and DevOps teams into this new way of doing work called DevSecOps. And it doesn't matter what label you use, but the concepts are what is really critical here, and especially the culture around those concepts. So here we want our development teams and our security operations teams to really work as peers, collaborate. So traditionally it's been a requester-approver relationship, right? At the last minute, you go, you request a security review, and then you approve it. And if you don't approve it, it doesn't matter because it's too late to make any changes. So we want to change that, right? And that is a big cultural change. We want to redefine how we can bring these three functions together. And then this final bit, that controls in that integrated CI/CD pipeline, is what is key. Remember what I just said. We are doing push button from the time a line of code is changed to the time that it's delivered is automated, right? And now this doesn't mean they're very, very, very strict controls, because the product gets promoted along that pipeline, but they are automated. How do we do the same with security? how do we start taking some of the controls? We had Veracode earlier, talking about code reviews and code scanning, and how do we make those so that our motto is clean before check-in, right? So the small bits of changes that our developers are making, we want to make sure are statically assured and dynamically assured before they're even checked in, right? So that changes the culture. It is not a security team running code scans. It's not that code scans are going off-site. It is part of what you do 20 times a day, right? And that requires cultural changes around how do we teach that, how do we monitor it, how do we make it work, right? So that is what I mean. Now, the other thing that we're trying to do is what we're calling codification of policies, right? So I'll give you an example. We have PCI compliance and other compliance that requires that there are policies around it, and we have to make sure that we adhere to those policies. Now, traditionally, policies have been written, and then there's some compliance and auditing that happens against them. And it is usually a manual process. And it's a compliance-driven process, right, of checks. And so more and more what we want to do is try to codify those. So an example is a logging and monitoring policy. So we have those, they're well-defined, and our products have to adhere to them. Now, if we could develop an API that implements that policy, and all of our products just link and use that API, now we've codified a policy, and we can very easily and automatically put that control in and make sure that it's being adhered to, right? Instead of kind of that compliance regime, which nobody likes. The auditing people don't like it, and the people being audited don't like it, right? We still have to make sure that those controls are being monitored somehow, but it makes the whole process different, right? So that's what I mean about how it changing the way that we think about things. I'm going to be careful about time here. I can talk forever, so that's this is a little tongue-in-cheek, and Agile Manifesto. How many people here have lot? So this is now almost 16 years old, 17 years old. I think it was in 2000 that the manifesto came out, and it changed our industry from the software point of view, right? DevOps, its roots are in Agile, right? So we have taken some of the work that Cigital has done and kind of started to craft our own security manifesto. And again, this is focused more on the software side of the house, but that is where some of the biggest cultural changes are taking place. So I'll go through a couple of these quickly and then a little more detail. So our manifesto says that we rely on developers and testers more than security experts. So we want to change this whole concept of security in an ivory tower or security as policemen and bring that into our DevSecOps pipelines, right? Doesn't mean that we still don't need specialists, right? We don't want everybody doing encryption, don't get me wrong, right? We definitely do not. But we do want everybody doing code, making sure that the code is secure, right? We want to be secure while we work more than after we're done. We want to implement features securely rather than just look at security features. Now, this is an interesting one because we spend a lot of time around things like encryption and authentication and authorization, stuff that is traditional security. But how many of you remember Heartbleed that happened a few years ago? I was at Intel then. It basically brought, our company to a halt. As we tried to chase down everywhere that it was in our ecosystems, in our products, and tried to mitigate that. And I actually went and looked at the code of Heartbleed, and it was nothing to do with security. It was in a little heartbeat function, right, that was just checking to make sure that the other end of the pipe was still alive. And it was a simple memory copy, copying things from one part of memory to another, right? And that caused that huge, gigantic problem that if we ever calculated the cost of Heartbleed, by the way, it still shows up, right? It would be enormous. So my point there is that we've got to worry about security as we're doing anything in the system. a heartbeat function had nothing to do with security, and yet that was where the security hole was, right? And finally, we've got to start looking at risks more than fixing bugs. This is, something that Ramesh is very near and dear to her. She's always talking about risk and not about a particular bug. And finally, we've got to build resilient systems because we know that our systems are going to be compromised. And how do we survive in the face of a compromise, right? So those are all big cultural changes. From bolting it on to building it in. DevSecOps is the start of this. The cultural shift is team-level accountability instead of accountability by the security team. Governance is key, but we want to automate it and make it as lightweight as possible. And then finally, as from the last slide, we really want to start thinking about security as a quality attribute. Just like resiliency, just like scalability, it is just another quality attribute that you have to build into the system. So this is just a visualization of a DevSecOps pipeline, and there may be many, many different implementations of this. This is kind of what ours looks like at Comcast. We just have multiple stages. The N is the number of stages, right? And the N differs from team to team. And the promotion of whatever piece is going through the pipeline, that promotion is automatic. So from N to N+1, there are some gates and controls that the product has to pass through, and then it automatically gets to the next gate and control. So what we've been trying to do, and again, that throttle release that I talked about earlier, and again, you see that on our pipeline, there is no staging stage, right? It goes straight from the last stage to production, right? And so that throttling bit has tremendous amount of capability built into it and tremendous amount of metrics and monitoring and so on. So our challenge was, how do we start putting security into that pipeline and make it from a DevOps pipeline to a DevSecOps pipeline? And so we picked a few practices that we've been focusing on, and the landscape is huge, and I don't want to claim at all that we're anywhere close to doing all of this. But we have picked a few that we're focusing on. And again, we picked the ones that can fit into that model and can be automated as much as possible. So the ones that we're focusing on is secure coding. And this, again, through training, through, we have a guild. We have a security guild where, groups, people from across the org come together and we talk and discuss and roll things out. We are doing secure APIs, static analysis, and moving it as close to the developer as possible. We've got several pilots that we did this year, and the results are pretty amazing. So, someday when I have more time, I'd love to talk about that. We're starting dynamic analysis and fuzzing. Again, dynamic analysis fuzzing requires a big, robust, automated test suite and models, which again, because we're in the DevOps culture, we already have, right? So in a way, we have a leg up there that at Intel, we were really struggling with this because we did not have, and not because Intel was, but because Intel had legacy, right? We had 30, 40 years of software that was not built this way, right? So we have that luxury here that we can do. We're starting to move test to the left. So some of the work that's being done here at UConn, for example, is prime candidate for this. So what we're trying to do is, instead of just doing security testing after the fact, we are working with our main product lines. We're developing test suites along with all of the associated tooling and the test cases. We bring the team in, we do a one-day workshop, we hand over the test suite to the team, and now they operate it. Right? So it's DevSecOps in the true sense of the word, right? We've just done this with one product line, so I don't want to make it sound like but it's been great because now we don't have to worry about, this is continuous assurance in the true sense of the word, right? The one thing that we're doing right now, which is not automated, is threat modeling. And that's a practice that we started this year, and it is really caught on. This is where our team comes together with our security architects and the development team and the operations team in a room, They spend anywhere from half a day to, so Shri was here yesterday, so for our Xfinity Home product, where this is critical that we get this right? We'll do several threat modeling sessions, and they'll span several days. But for our smaller teams, they may be a half-day session. But the team gets together, we draw the architecture on the board, we identify the threats, we put in mitigations in place, becoming really popular. People are pulling instead of pushing, right, on this. So besides threat modeling, every other thing that we've done is we're trying to automate and build into our pipeline. The final thing that I'll close with and then open up for questions is, this is, how many of you have read the book Black Box Thinking by Matthew Syed? So I would really encourage, especially us in this community, to read that book, because he talks about how we learn from failure, and especially from a cultural point of view. So the black box and the black box thinking comes from airline black boxes, right, that flow on, that fly with airlines. And the whole book is about the difference between two industries in our country right now. The medical industry, where we have a leading cause of death, third leading cause of death in the US, are medical errors, right? Last year, I think it was like 400,000 medical errors. 400,000 deaths that were a result of medical error, right? Now, you look at the aviation industry, and there, the latest number for IATA members is, I hope I'm getting this right, 12 per 8.5 million flights. 12 accidents, not deaths. So 400,000 deaths per year versus 12 accidents for 8.3 million flights, right? So, and my numbers are close. Sometimes you don't want to be too precise, because then you're really wrong, right? And the difference between the two industries is this black box thinking, learning from failure, right? And here is a example of this, and this is a picture from the book, so I have credit here. So this is World War II, and what was happening is our bombers were getting decimated. So the average survival rate for a pilot in World War II at the beginning of the war was less than 50%, that they would survive an entire engagement in the field. So what the Army started to look at was, how can we start making our bombers, the planes themselves, more solid, right? And so they started thinking about, how do we armor plate or Now, the problem is, you can't armor plate an entire plane, because then it won't fly, right? So it kind of loses its, that's the availability part of CIA, right? So they started working with some mathematicians, and the person who led this, very ironically, was a guy called Walt, who was a Jewish refugee from, and worked at Princeton. And the Army was collecting a lot of data. So he had a lot of data about the bullet holes that came, or the holes in the plane that came back from these missions, right? So they started looking at that data to go, what is the optimal place that we need to start reinforcing our planes, right? So the data was really clear. It was showing them that most of the holes were in the fuselage or in the wings. They weren't in the cockpits, and they weren't in the this back tail area, right? So the conclusion was what? What would the normal conclusion be? That let's start plugging those holes. Let's start putting something to protect that part of the surface. Well, it turns out that Wald did black box thinking, right? And he was like, I'm not going to just look at the data on the surface. He was like, these are the planes that returned. What about the planes that didn't return? That's where the deaths happened, right? That's where the casualties were happening. And it turns out that all of these bullets were really not that important, because the plane was still able to fly back. The area that was critical to protect was the cockpit and that little back wing area, right, in the rear of the plane. And it turns out that once they protected those casualty rates started dropping. So my point here is that that kind of black box thinking really requires a cultural change. The whole book is fascinating. It talks about the culture in the medical industry where failure is just, it's awful to fail, versus the airplane industry where every failure, there's an entire built-in culture about the failure becoming a way to improve the process, right? So the next time that you have a red team and you get all of the data, from the result, my challenge to my team and to everybody is to start doing this black box level of thinking and go, what are the holes telling us about the areas where there aren't any holes, right? That's where we need to focus our attention, not just the whack-a-mole stuff that we do today. So with that, I'm going to close. And am I on time? I think I am. So I'll leave some time for questions if there are any. Otherwise, we'll take a break outside. It's a beautiful day. So.
Thank you, Noopur.
Thanks.
So, first, I was thinking about one thing as you were discussing this. It seems like some of the software issues that you're describing are both microscopic and macroscopic. And your Heartbleed example, your recollection of that, is a case where something terrible happened because of a microscopic issue.
Yes.
That was not necessarily security-centric
Yes.
to begin with. So how do you actually bring security into DevOps while actually being able to look at issues that may have their origin at any kind of level
Yes.
in the spectrum, from
That's
micro
an
to
excellent question. So if you looked at the practices that we picked, right, they're addressing both micro and macro. So threat modeling is the bigger, and then code analysis is the smaller. But I want to make another point, and I actually have some data which I can share with you guys. Somewhere in the mid-2000s, when I was at Carnegie Mellon, what we started seeing was that there is a tremendous correlation between quality and security, right? So the higher the quality of the code, and I'm going to say code because that's the artifact that actually gets shipped, but there's a lot of other things that go into it. But the quality of the code and the security of the code, it was like the R squared was something like 0.8. It was like really high correlation. So just recently, we did, I talked about the pilots that we're doing where, clean before check-in, right? So our XRE guide team, so this is, when you were, how many of you are Comcast users? Awesome. So when you use the guide, right, that is a tremendously complicated piece of software, if you can imagine all of the work that happens to build that guide, right? Because it's real time and there's all kinds of legal and issues about where channels are going to be placed. I'm learning all this. I'm new to this industry. So our XRE guide team was one of our pilot teams, right, for our static assurance. And it turns out that we ran the static assurance tools, integrated it into their pipeline, and we found 12, like a handful of errors. And it turns out that none of them were, that none of them were really important. Now, I've been doing this for a very long time. This has never happened. So we had the vendor come in because they were like, oh, you must have something configured wrong. There is no way. This was over 400,000 lines of Java code. This wasn't something, tiny, right? So the vendor came in, they looked at everything, and it turns out everything was configured right, and it was indeed. So I was like, I've got to find out more. I've never seen this. So I started digging in. It turns out this team produces some of the highest quality code in our company, right? And they have a process where over and over and over and over again, they look at their code. They do manual reviews. They have integration with SonarQube. They run complexity analysis. They know their code, and they know at the microscopic and the macroscopic level. And if you look at just the quality of their software, they have very few bugs. And like I said, the static analysis tools found 0 in over 400,000 lines of Java code, right? So it's a really, really interesting question. And I think the way to get at is to be that way, where you treat everything that you do with seriousness. Yeah.
Great. As a follow-up, you were actually mentioning also that in the first part of your talk that applications, some teams want to own the entire stack, the whole
Yes.
application, but somehow you are decomposing in layers
Yes.
with few ports connecting them. So how does that integrate with the SecDevOps process where your application might be even physically separated with components on mobile device or they're in the cloud? How is this approached when an application is so diverse in how it is being deployed?
Yes, so I didn't mean this, sorry, I didn't mean that there's one instance of the app layer and one instance of the web layer and one, right? So it could be scaled across multiple VMs and data centers even, right? Depending on the scale of the app. But what I meant was virtually it's connected through a virtual port. Does that make sense? So you're absolutely right. Depending on the scale of what you're doing, this could be scattered across multiple teams and across multiple. But that entire stack would be owned by either a team of a few, depending on how big the application is, or a team that is a multi-team, right? That is a product line team. But they still own the whole thing. You know, they from the beginning to the end.
So you're using hierarchical Scrum methodology.
We may use a hierarchical Scrum methodology or you know, a scaled Agile methodology. Or now we don't use any of those you know in its classic form, but we use parts of them in the way that we're building.
Great, thank you.
Yeah.
Let me turn it over to the room. Are there any questions? Please.
Oh, we are that is one of our goals so the question was, how do you look at chaos monkeys, right? So that is one of our goals. Is with DevSecOps you can still do the same thing that you do with just DevOps, right? One of the things that we're looking at is, by the way, that continuous assurance bit that I talked about earlier helps with that. Right? So let's say that I unplug something, right? And that something happens to be a control, a specific control that is important in my DevSecOps pipeline. So now I have to have a system that responds and is resilient to that being unplugged. So that same model applies for security as well. In that, sorry? No, we do not. We haven't done that yet. So by the way, I don't want to leave with any wrong impressions, right? So what I'm describing here, even the DevSecOps, 3,500 releases a year. So that is part of our organization, right? That is our X1 platform, the newest part of what we do. But you know, we still have parts of our organization that don't run this way, right? So I'm talking about, you know, now X1 is our premier and key platform. Right? That is where most of our growth is. So we're doing it in the most important part of our organization, but it is not all over. And no, we have not done that yet. That would be good. I'd love to come back and talk about that in a couple of years, if we ever get brave enough for that.
Okay. Another question?
As a member of the team, I'm pleased I got to hear you speak this morning.
Oh, awesome.
I'm just wondering, as relatively new eyes to our organization, what do you think our biggest security challenge is for, let's say, the next 12 to 18 months?
I think just these two things that we talked about here. You know, one is our scale. I still can get my head around that. So I have a lot of sessions with Jim and others, just like teach me. Because you know you know, Jim has lived with this scale for much longer than I have. So I think our challenge is again scale, the technology, the change in technology. That network we run is changing in these ways that I've talked about with SDN and NFV and all of these bits coming in, and then the culture. Right now we have parts of the organization that are true DevOps, doing 3,500 releases a year. And moving more and more to a mixture of public and private cloud. And we have our more traditional security organization and our other development organizations. And how do we bring that culture together? So I think it's those three things: the scale, the technology, and the culture. And I think that is probably true just about anywhere except the scale bit, right? The technology and culture bit is I think, something that everybody's dealing with.
We have time for more. Ramesh?
So in the room we have many folks from different universities teaching the next generation of the workforce. What would be your advice or recommendation in really getting the DevOps culture kind of incorporated in the curriculum and getting that to be part of the process of their training, so that before they join the organizations, whether of the scale of Comcast or other companies, it's kind of built into their thinking?
Yeah, that's a really good question. And again, when I was at Carnegie Mellon, in the early 2000s, we were developing some of those curriculum. And unfortunately, we didn't have as much influence as we wanted to, because we were still the security people, working in CERT I've actually thought about this quite a bit. And I think there are some special courses that we need, things around encryption and so on, which are very security-centric. But otherwise, going back to your original question, the micro versus macro, I think we have to build it into everything that we teach. I don't see how we can teach coding, whether it be C or C++ or C# or Java, or without talking about the security aspects of that. If we do a network class, how do we teach networking without talking about the security aspects of that? So architecture, metrics, data analytics. I think that entire fundamental computer science and engineering curriculum have to have security kind of woven in, and not as a now I'm going and taking a security class, right? Which we need for some topics, but we have to start thinking of it as part of what we do every day. Like that XRE guide team, they think about their code, they think about their design as just part of what they do. It's not like, today I'm going to put on my security hat and think about security, right? So that's just my my opinion, I guess.
Time for one more question. Hello?
Working.
So these are all members of my team. So Kayla, what the?
Morning, Noopur.
Hi.
Just a quick question. I know you have a lot of appreciation for academia, R&D. So from your vantage point, where do you see this relationship going with UConn? And in the next 12 to 18 months, what else do you think we should be doing or focusing on from an R&D perspective?
That question I would like Ramesh to answer. So I'll be very open with all of you. My new job, so I started at Comcast in January, and this new position as CPISO is about 6 weeks old. So the whole UConn relationship is very new for me. I'm just starting to explore and learn about it. So I'm going to leave that question to Ramesh. Ramesh, would you please? I'm putting you on the spot there.
As Kayla was asking that question, it's like, he's such a troublemaker.
I know, really, Kayla. You asked the one question. I don't. No, I'm just kidding.
But I think just obviously the relationship with UConn is not just to the scholars, unique to the scholars at UConn. The relationship Comcast at CSI kind of has a global umbrella where we are engaged with other scholars across the nation. So just to begin with that, we will have a combination of applied research as well as ongoing initiatives that we have with UConn, as Noopur referred to, on the hardware security side of the house, the assessment work that we're doing, and how do we bring that, test cases and the learnings from those types of initiatives into Comcast and teach our engineers to kind of incorporate that into the security culture that Noopur was talking about. So just on a high level, those would be the focus for us with UConn in the next 12 to 18 months.
Yeah, and the applied part of it is the part that I do know. We have a quarterly guild offsite, and we had a couple of UConn professors come and talk to us. And I was really impressed by what you were there, by what you showed us, because remember that example I gave earlier that we have built a security test suite that and we spent quite a bit of resources to do that. And what you presented to us was exactly that you've done. In fact, some of the tools and techniques we used were what you had used. So now we transferred that to our team. And I would love to see that same thing happen, is that when you build these things, that you come up to Comcast, you talk to our engineers, and you transfer that to them so that it becomes part of their daily ways of doing work, right? That is what I'd love to see. Because my goal, again, I talk about culture a lot, and I think those are the type of things that change culture, because now they own it. It's not those UConn guys who'll do this, or those security guys who'll do this. It's we are the ones doing it, right? So.
Absolutely, and with that thought, I think that we should join me in thanking Noopur for this really inspiring talk. Thank you very much.
Thank you.